Okay, here we go. Trapezoids and kites. We'll start with probably the easier one, which would be trapezoids. I said that there are 3 more, but there's only 2 in the title because we have a special type of trapezoid that we'll get to eventually. So, here's a trapezoid. What is it? Logan.
It's a quadrilateral with 2 opposite parallel lines, but it's not a square.
Do we need the not a square thing?
Yeah, because if it had, because it's only 2 parallel lines. Yeah, I removed the square.
Okay, good. Well done. Quadrilateral with exactly 1 pair of parallel sides. Not 2. Okay, it's off by itself. So now you can start to think about the other figures we've talked about and what they had in common versus this guy, which has very little in common with the other ones. Seeing that picture, you hear that too, right?
Yeah.
Okay, good. Sometimes it's the voices. What can you tell me about that figure, other than the fact that it's got 1 pair of parallel sides? For instance, what's the relationship between angle turtle and puma? Don't be bashful. Just fire right. Just throw it out there. How should we go? Beautiful. They're supplementary. See, you knew the answer. You're just too afraid to say it, Robert. Same side interior angles. Angle T is congruent to. Is supplementary to angle P. Angle R is supplementary to angle A. What's the relationship between angle Puma and angle aardvark? Excellent. There is none. Let's move on. Okay? So, the 2 sides that are parallel we commonly call a base. This is different than the other shapes. We had nothing called a base in a parallelogram or square or anything like that. The non-parallel sides, any guesses? Those are called legs. In a trapezoid, the legs are not congruent. The bases cannot ever be congruent. They just happen to be parallel. Say again, I'm sorry.
Wait, are they the same number?
They cannot be the same number. TR can never be congruent to PA, because if it is, then it's no longer a trapezoid, it becomes a parallelogram.
So like
Wait, hold on, one at a time. Lily, go.
Oh, never mind.
I can help. Logan.
So trapezoids just have no congruent sides?
Nope. It's a pretty boring shape.
Wait, can T and RA be congruent?
Can,
TP and RA.
ooh, that's an excellent question. Can you wait a couple minutes?
Yeah.
Because I will answer your question shortly. Other than the sides being parallel, well, let's get some more terminology together. P and A are considered base angles because they share the same base. T and R are the other pair of base angles. Okay? The consecutive non-base angles, let me say that again. The consecutive non-base angles are supplementary. That's a fancy way of saying T and P are supplementary and R and A are supplementary. You need that once more?
Yeah.
Consecutive non-base angles are supplementary. All you really need to remember is same side interior angles, okay, between the parallel lines. And you'll be good to go. Adds up to 180. Okay. Those are not congruent. Said that already. Those are not congruent. All right, here we go. Said that already. Consecutive non-base angles are supplementary. And then there's nothing else exciting about this trapezoid. It's boring. That's it. There's a little joke in there that I hope you all understand.
Because I'm always in
Yes? Do we all get the joke? No?
I wasn't very funny. What?
So you're doing a quiz. If you want to show that something is a is a trapezoid, we're going to introduce a different concept here that we're going to use a lot, and that is not only do you have to show what is true, you also have to show what isn't true. I'll say it again. If you want to prove that something is a trapezoid, you have to show what is true, but also what isn't true. By that I mean, if we go back to the picture of this trapezoid, if I want to show that's a trapezoid, I clearly have to show that TR is parallel to PA. Easy peasy, right? Do slope, you're done. However, that doesn't guarantee it's a trapezoid until we figure out that TP and RA are not parallel. Okay, so we're going to have to do some not stuff here. These sides are parallel, these are not. Trapezoid. These sides are parallel, these are also parallel. Now we got a parallelogram. Okay, and that's going to happen a lot when we start working with the hierarchy, once we get that hierarchy constructed. Okay? Which is that? Okay, so Lily, back to your question. You asked me what?
Are TP and RA?
If they are,
Wait. Concurrent?
yes, if they are, we get an isosceles trapezoid. One of those guys. Just like a plain old trapezoid, except the legs are equal. And again, remember, bases can never be equal in a trapezoid. Just like an isosceles triangle has two equal sides, an isosceles trapezoid has two equal legs. And then all kinds of fun things start to happen now. For instance, because it's a trapezoid, F and G are supplementary. R and O are supplementary, but now the base angles are congruent. G, gopher, is congruent to octopus. F is ferret is congruent to raccoon. Am I going too fast or are we okay?
Wait, 2 seconds.
Okay, hold on, let me click. I'll give you this. Oh, we'll save that for a second. Have we talked about the phrase if and only if yet? If and only if. Have we discussed that before? Okay, this is a good time to start. If and only if is what's called a reversible statement. Okay? So if I was to say to you, I have a wife, if I have a wife, then I'm married. Is that a true statement?
Yeah.
Okay. What if I reverse it? If I'm married, then I have a wife. Is that a true statement?
No.
Why not?
You could have a husband.
I could have a husband, correct. Okay. You with me? That is a non-reversible statement. It's not the same forwards as backwards. Can you think of an example of one that would work forwards and backwards? Sorry? If I'm a dog, then I'm a golden retriever. No. If I'm a golden retriever, I'm a dog. That's a true statement. But if I'm a dog, doesn't mean I'm a golden retriever. Okay.
Yeah.
Any other ideas? No.
Oh, if I'm an obtuse angle, I'm an angle.
But if you're an angle,
Wait, what about if yeah, that's right. If I have a heart, I have blood.
if you have blood, you have a heart.
If you have blood, you have a heart.
That's not horrible. Good. Okay.
Yes, snaps. Snaps.
You could even twist that a little bit and say, if I have a beating heart, then I'm alive. If I'm alive, I have a beating heart.
Yeah.
Right?
Yes.
Assuming you weren't like you weren't in a UFC match and just like punched through some guy's chest and pulled out his still beating heart and showed it to him. That would be weird. But in general, that's a true statement. You got something? Ooh. Everybody hear that?
Yeah.
Okay, good. Any others?
Oh, if I'm a builder.
What if you're at home doing your homework? All right, so anyways, the point is these if and only if statements are reversible. So what it says up there is if the base angles are congruent, then it's isosceles. The reverse of that would also be true. If the trapezoid is isosceles, then the base angles are congruent. So what it does for us is it allows us to get two things stressed with one statement. Okay? Questions? Beautiful. The diagonals are congruent. In a regular trapezoid, they're not. In an isosceles trapezoid, they are. FO is congruent to RG. Okay, we good? Let's go back to this picture. See where those two tick marks are? Let's assume those tick marks pass through the midpoint of the legs. Okay? If I connect those midpoints, I get something that's called a mid-segment. It looks, I think I have a picture of that. I don't. Okay? So, let's go back to this picture. If I draw in the segment that connects the midpoint of the legs, I get what's called a mid-segment of a trapezoid. Okay, let's call that X, let's call that Y. And that mid-segment has a number of properties. The biggest thing is that its length is the average of the other two sides, the other two bases. Yeah, I got it right here. That's what it is, and that's its property. It's parallel to the other bases, you can see that from the picture, and it's the average of the two lengths of the bases. Add up the bases, divide by 2. Be good to go. And so you can imagine the types of problems. Here are the two base lengths, how long is the mid-segment? Here's the mid-segment and one of the bases, how long is the other base? Before we move on to some examples, is an isosceles trapezoid a trapezoid?
Yes.
Yes. Is a trapezoid an isosceles trapezoid? No. Okay. Dog, golden retriever. Is a trapezoid a parallelogram? No. Only has one pair of parallel sides. Is a trapezoid a square? Is it a rhombus? Is it a rectangle? No. In other words, trapezoid does not play well with other quadrilaterals. Okay? A trapezoid and its evil cousin, the isosceles trapezoid, are over there playing by themselves. Don't get along with the other quadrilaterals. Okay? Let's do some work. Well, yeah. We don't. Now, in an essence, I'm not even speaking English. In an effort to save time, I'm going to go through this quickly. If I knew how long TS was, turtle salamander, I would add turtle salamander plus 26 and divide by 2, and I would get 38.5. I don't know how big TS is, so I would assign some variable to it. I don't know, X. And then I could set up an equation. x plus 26 divided by 2 must equal 38.5. Giving you TS and HA to find RM is way too easy of a problem. We want to elevate it a little bit. When you do that, you would get 51. Why? Because 51 plus 26 divided by 2 is 38.5. And I'm going to assume that you can solve a simple equation like that. Okay? Average. X plus 26 divided by 2 equals 38.5.
And then X ends up equaling
All right, now we move on to our last quadrilateral, a kite. A kite is exactly what you think it is. It looks like a kite. Hence the term, kite. It looks like that. By definition, it's a quadrilateral with two pairs of consecutive congruent sides. Now you gotta be careful. The consecutive is the important part here. In other words, the two sides that are next to each other are congruent, not opposite. If it's opposite, it's a parallelogram and all those other guys. Is that a trapezoid? No. Is it a parallelogram?
No.
No. Is it a square?
No.
Rhombus? Rectangle. So again, we have a shape that doesn't play well with others. It's so bad it doesn't even get along with the trapezoids. And again, you want to think about that as you're envisioning what your hierarchy is going to be for quadrilaterals. I would equate the kite to the gorilla in the living things hierarchy that you did. I think it was the living things one, wasn't it? Or the gorilla was off by itself? Okay. Just from looking in that picture, what can you tell me about the diagonals of a kite? They're perpendicular, correct? Is it safe to assume that you've all flown a kite?
Yeah.
Yeah? Okay. For those of you that haven't, it's okay, no judgment. If that was an actual kite and I was going to go out and fly it, I would tie a tail to the point T. And then I would tie the string to the point of intersection between the diagonals. Okay? So the point where you tie the tail, which is T, and the top of the kite are what's called the ends of the kite. Okay?
We go play kites.
Sure. Not right now.
Well, not now.
Okay, at some point, sure.
In math class?
Yeah.
Yes.
Yeah. Some of you I would even let go plane traffic. I just want to say,
Shoot.
from a legal standpoint, that was a joke. Okay, so when we do go outside and one of you gets run over by a car, I don't want to be found guilty of encouraging that behavior. So again, you've all heard me say that was a joke. So I don't have to end up in court testifying how Lily ended up in the middle of
Are you
Kensington.
recording?
I am, so it's now on record that this slideshow could become a legal document to prove that I was not encouraging Lily to go out in traffic with a kite.
Was flying the kite?
See me what?
also you?
I see you or cute.
No, they just see the board here, but you see board, just see board here. Me talk, them listen. Great. All right. As Juliana already mentioned, the diagonals are perpendicular. Hot diggity. There's exactly one pair of opposite angles congruent. One diagonal is the perpendicular bisector of the other. It's a lot of information, but look at it logically. Okay? Does this is a visual look up here, does this equal this? No. This equals that though. Okay? It's perpendicular. It's bisecting, therefore it's a perpendicular bisector. Does this angle, T, match angle K? No. Angle I does, however, match angle E. You can fold that kite in half, top to bottom, and it will match. If I fold it left to right, it ain't gonna match. And in fact, trivia question, if we have a figure where the diagonals are perpendicular and you can fold it in half left and right and top and bottom, what kind of shape do you have?
Let's try.
No, it'll be a quadrilateral.
Wait.
If I can fold it this way and it matches, and I can fold it this way and it matches, what kind of figure do I have? Could be a square, also known as, you're right, also known as, that's what I'm asking you. It's a rhombus. Could be a square. We're going to skip the problem because of a time constraint, but you would simply do the Pythagorean theorem a couple times. Got a bunch of right triangles. If RT is 24, then this distance is 12, and that distance is 12. Pythagorean theorem, add up, solve. Done.
That's pretty cool. Wait, how was your time? Just like,
Add all the sides up. Find RA, find RS, add them up, double. Okay. These transitions seem like a good idea until you're standing here waiting for all those things to drop from you. This one will do. How big is angle U and angle S?
pretty big.
Oh yeah.
Okay.
What do you got on break? There has been a suggestion that 83 is the answer. Can somebody confirm?
Yeah.
83? Let's see what the clicker says. Doink, 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 doink. 83. Jackson, why? Could you enlighten us a little bit as to how you did that? Like, what did you type into your calculator? Or did you just like go into a fugue state and the math gods controlled you through them?
Four sides, so I did minus 2 times 2 times
No, 132 plus 62. Find the total of that minus that. Divide by 2.
Can you redo it?
What he said, translating is, it's quadrilateral, the sum of the angles is 360. He realized that angle U and angle S are congruent to each other. So he took 360 minus 132 minus 62 to get that total, divide that total in half, and those two angles are equal. Okay?
These
Oh.
was it 82?
83.
Yeah, look at big one big one right down. Well, I forget there is.
We got that for early.
I do one of the